Hi, good morning, everyone.
Good morning.
How are you doing?
Pretty good. Got the coffee going.
Nice. Me too. Me too. Yeah. That's what you got to do, huh? Yesterday in my other class, the one I have in person, someone asked me, "What kind of coffee do you drink? Because you have so much energy." And I said, it's probably just, I don't think it's the coffee. I just trying to make class more interesting." And then anyway, I thought that was funny. It's all fake, okay? It's not real energy. Oh, someone asked, where can I get the worksheets from that we had due? Oh, in math, you mean from last week, the one from last week, or today's worksheet? Huh. Maybe I can link either in the chat here. Let's see here. No, not that one. Wait for it. Oh, so the worksheets, I mean, all the worksheets that have been past due or whatever they're due, actually today's worksheet as well, they're in Canvas. Maybe I can show. So if you go to, Canvas, you log in and then click on our class, Math 33, not Math 111. So that'll, Math 111 obviously has all the homework and quizzes for Math 111, but in Math 33, you'll see, so all the recordings of our Zoom sessions, and then links to the PDFs of the worksheets, and then also places to upload them, of course. But last week's, let's see, so the worksheet we did Thursdays here, and I wanted to talk a little bit about that because someone reminded me that I forgot to upload the video of our Zoom session on Thursday. I usually link them within the submission thing, and I didn't. So just in case, that was not an easy worksheet. I think if it was easy, then it wouldn't be a big deal, but it was a difficult worksheet. So in case you needed to go back, I'm giving more time here, because let's see, I think I'm gonna change the due date for that guy. That way you have more time to do it, if that sounds good. Yeah. And today, actually, the worksheet for today it's fairly short and simple. I don't know, in math usually nothing's that simple, but relatively speaking, it's fairly simple. So I think today it won't take too long. We'll go over what we need to go over, and then might end class early or end class if you need to ask questions, and then you can go ahead and work on that. But I'm going to change the due date so you can have more time to do that one, and also the factoring one is definitely has extra time to do that. Oh, someone asked, do we turn in what we have, or sorry, do we turn in what we do here in class, or complete it on our own if we do not have? Yeah, I think just pretty much for the worksheets, whatever we complete in class is what you can turn in. So like on last Thursday, we pretty much, I think it took us a while, but we completed the whole worksheet, every example. So you would turn in, either photographs, or you take photos of your work or scan it, or however you want to do it. But yeah, just everything we go over in class, and I think we covered everything there. And then, like we said last week, the factoring worksheet, that was extra credit, so that's you don't have to do it, and it's not due until this coming Sunday. And I think I'm going to just go ahead and change the due date for that last Thursday's worksheet right now before I forget. I'm sorry, but I saw someone, they had their hand up. Sorry, did you have a question, someone?
Yes, it's for the homework for 2.8. It's where, okay, I'm gonna share my screen so I could show you.
Okay.
Okay.
Do I have
Okay. See me? Yes, okay. So, hello. So, for 2.8, okay, can you see this right here? How could, how you gotta get, is this a 43? I think it's a 43. You know how you get the 43? How do you get to this, to be exact?
Oh, good question.
Because I tried to like figure it out, but I don't know how to do it.
And that's actually perfect. That's awesome that you happen to ask that question, because that'll help with today's worksheet. So maybe we'll go. Yeah,
Okay.
thanks for asking, because simplifying the roots, that's not easy.
No, I never understood that from high school.
Yeah, and then they just expect everybody to remember it. Oh my gosh, so it's a good thing to review. Good idea. Okay.
Okay, perfect. Thank you,
You're
Professor.
welcome. Oh, no problem. Thank you for asking.
Yeah, no problem.
And then somebody, I can't remember who it was, but this morning I just checked my email and someone was asking about a specific homework problem. Is it in the same section? It might be in that same section. Maybe not, but we can go over that too, I thought, because that might help everybody. But maybe first, yeah, we'll do like you said, simplifying roots. So simplify roots or radicals, sometimes they call them, but they're, you know, square roots, cube roots, all that fun stuff. Radicals. Okay. Because that's a good example, actually, that one that you had on the homework. It was, and within section 2.8 in Math 111, we'll be doing things using formulas to find distances from one point to another. You might have already even jumped into it if you're ahead in class, but once you use the formula, your answer will look something like this. It'll have a square root of a number, and that's the correct answer, so it's fine, but it's not simplified all the way. And you don't want to put that in a calculator, because as soon as you put a number in a calculator like this, the square root of 45, all of a sudden it's a rounded number. It's because this number itself, right, the way it is on the screen is exactly correct. It's exact answer. But as soon as you put it in a calculator, you have to round it to a certain place, and now it's not exact. It's an approximation. So on the homework, they don't want any approximations unless they specifically say, okay, what's the answer? Round your decimal to the nearest 10th or 100th. If they say something about a decimal and rounding, then I guess they do want the approximated answer with the calculator. But otherwise, for something like this, you're supposed to think to yourself, okay, when I see with a number inside the square root, I think, what is, you might already know this, but if you don't, hopefully it's helpful. What is the largest number that divides into whatever number's inside your square root? So in this case, 45, that has a square root. So and that's kind of hard to think about, but if you want, you can always make a list of all the numbers that have a square root. So kind of reverse engineer it. What numbers have a square root? They're the numbers that are a number squared. So like 1 squared is 1. What's 2 squared, or 2 to the second power 4? 3 squared is 9. 4 squared is 16. So if you want, you can just have this list kind of in your head, these numbers, or you can actually write it out every time you need to do this, and then so on and so forth, 6 squared and on and on. But so these are the guys I'm looking for to divide in: 1, 4, 9, 16, 25. 6 squared would be 36, and then 7 squared would be 49. And I could keep going, but that's what I'm looking for. One of those, which one of those is the largest number that divides into my number that's inside the root, 45, that has a square root? So I'm looking at it, and I guess the main thing is you want the largest one. If there are multiple that would work, I want to pick the largest one. So I can start with, 7 squared is 49, but 49 is not going to divide into 45, of course, because it's bigger. 36 doesn't divide into 49. Oops, sorry, 45. Okay, how about the next one? 25 won't divide into 45. No, 16 won't either, but I think 9 does. So that must be the biggest number that divides into 45 that actually has a square root. I mean, if 45 was a number that had a square root, like if it was 49 instead, then the answer would just be 7 and you'd be done. But if it's a number inside your root that doesn't have a square root outright, then okay, I can't take the square root, but at least I can split it into 2 pieces, one of which actually has a square root. So I'm going to write 45 as 9 times 5, even though 5, I know there's no hope of simplifying that because there is no square root of 5. At least part of it, the 9, I can simplify. I'm going to write 45 as 9 times 5. And then one of the rules of radicals is if inside your radical you have 2 numbers multiplying, you can split it into 2 different roots. So it's like you can take the square root separately and then multiply. So I can write it as, square root of 9 times square root of 5. And then at least that way, one part of that I can simplify. I know the square root of 9 is 3 because, the square root means what times itself twice is this number. So of course, 3 times itself is 9. And 5, there's no way to simplify that, but then that's as good as it gets. So this, if you were to put this in your calculator and, on one hand you type 3 times the square root of 5, you get a certain decimal. And then also if you type in square root of 45 and you get a different decimal, I mean, they'd be the exact same answer. So those are the exact same answer, but this one is technically, they call it simplified. Even though the square root of 45 is the right answer. Yeah, it's not simplified all the way. You can make it look nicer, I guess, is the idea. So, and we'll see a lot of that today in our worksheet that we're going to go over. So that was kind of a perfect example to go over, or, a perfect topic to talk about. Yeah, maybe we can look at another one. I don't know. Did I leave enough room on this little whiteboard thing? I don't know. Let's see. So the square root of 45, what else? How about let's see. How about, okay, here's an example. How about square root of 32? I mean, of course, it could be a bigger number, but hopefully it's not too big, and depending on your homework problem. But something like that, I'd say, first I'd say, okay, does 32 have a square root? No, there's no number that I can raise to the second power and get 32. So, okay. So then my next question would be, it's kind of the same thing as we saw in the stop bubble. What is the largest number that divides into, but now 32 that has a square root? So I'd go back kind of to these numbers that that I wrote down here. These are the ones that have square roots, like 49. There's no way that's going to divide into 32 because it's bigger. 36, same thing, it's too big. 25, no, 25 doesn't go into 32, but 16 does. 16 times 2 is 32. So that's a good idea. I'm going to split that. I write it as 16 times 2. And then I'll give the 16 his own square root, give the 2 his own square root. Okay, and that's helpful because 16 actually has a square root. It's 4 square root of 2. So that would be another example of a different root simplified. And I wanted to do one like that because this is an example of why it's important to, when you think about this, what is the largest number that divides into your number that has a square root? You always want to look for the largest, because you could mistakenly, in this example, look at 32 and say, okay, what 32 is what times what? Okay, it can be 4 times 8. So you might accidentally say, oh, I can write it as 4 times 8 and then simplify the 4 because there is a square root of 4. So I'd go, oh, the square root of 4 is 2 and the square root of 8, there is no square root of 8. And I think I'm done, but really the answer should be 4 square root of 2. You kind of, I think you extracted a piece of 32 that had a square root, but there was more you could have extracted. So if I were to have done it this way, where I find something that divides in like 4, but it's not the biggest thing that divides in that has a square root, it'll still work, but I'd have to do it. I'd kind of have to do the whole process again. Once I break 32 down into 2 square root of 8, like we see here, then like if you type that answer in my math lab, they'd say, although the answer is correct, it's not simplified all the way. I'd have to break it down again because the square root of 8 can be broken down more because 8 is 4 times 2. So it's possible to simplify it by extracting a piece of the number that has a square root, even if it's not the largest, but you're going to have to be taking a long time to do it. You'll have to do it multiple times. So it's really in your best interest to think of the biggest or the largest number that divides in. So like we did here, 16 is the biggest number that divides into 32 that has a square root. So I want to do that just to save myself time. I will only have to do this process once instead of twice. Yeah, but sometimes we don't happen to think of the largest one, and it's kind of good to know, I guess, that it'll work either way. I can do it this way with 4 and 8. I just have to break the 8 down again more. Maybe we can do it real quick if I erase this stuff here, then just to see, that no matter how you do it, even if I don't find the largest number that divides in, at least I'm still going to get the right answer. So if I were, for some reason, I saw 32 and I said, oh, I think that's 4 times 8. That's as good as it gets. So I would have written it as 4 times 8. And then I know 4 has a square root, but 8 doesn't. But then it's, like I said, the 8 has something that divides in that has a square root, another 4. So I'd write 8 as 4 times 2, and then give that 4 its own square root, give that 2 its own square root. And then it'd be, okay, there's a 2 in the front, but the square root of 4 is 2 itself. So it's kind of like the 2 that was already there is now being multiplied by a new 2 that came from the square root of 4. And then that last guy, the square root of 2, there's no hope for him. That's as good as it gets. And then since there was already a 2 in the front, but now I've introduced another 2 in the front after taking the square root, those would be multiplied together, 2 times 2, and it would give you this exactly the same answer that we got, but it took longer because I didn't think of the biggest number that divides in. So I had to do the simplifying process twice instead of once. Yeah, that's a super quick rundown of how to do these.
Yeah. Hey, sorry, Professor, to interrupt. What are we going through? What have we been going over so far?
Just how to simplify radicals or roots. If you have a number inside a square root that it maybe doesn't have a square root, but like you can write it as a product of 2 things, and one of which does. Like, so this one, 45. Someone had this in their homework problem. I think it was a bigger homework problem where they were calculating something, and then at the end they got square root of 45. But on my math lab it says that's the right answer, but it's not simplified. So they want you to write it as the product of 2 things, one of which has a square root, and then continue from there. And I think I've had students, when we're going over something like this, an example, they say, like if this was the problem they were given, okay, square root of 45. Oops. Well, I can write 45 as, and they think of a different product, like 45 could be 15 times 3. I don't know if if that's the one you happen to think of first. But that's not really helpful because neither 15 nor 3 has a square root. So I mean, 45, yeah, it is 15 times 3, but that's not really helpful. You want one of the numbers in your product to actually have a square root. Otherwise, it's not helpful to you to split it that way. Yeah, but this way was good because 9 actually has a square root, so it's going somewhere. Yeah, that's kind of that's the long-winded way to say how to do it. But we'll do more of these simplifying within the worksheet today too. So I think that'll help reinforce it too. But before we move on, what do you think? Do you have any questions about just this so far, what we've done? These two examples, square root of 45, square root of 32.
Can we go back to square root of 32 since I wasn't present at that moment?
Yeah. Okay, so what do you have any questions about it?
No, Professor, I meant if we can go back to the example of square root of 32.
I kind of I don't want to go over the whole thing because it might be not fair to everyone that was here to have to listen to it again. You know, does that make sense? So maybe, I think today, like I was saying to everybody, we're going to end probably early because it's a shorter worksheet. So that can leave room for any questions. Maybe anyone that missed this example, we can go over that, or homework problems, or part of the worksheet or something. But I think just because, yeah, there were a lot of people that were here and they were listening and they don't want to have to hear that again. So someone else, I can't remember exactly who, but someone else asked about a certain homework problem. Let's see. And it kind of has to do with what we did on this past Thursday, you know, the inverse stuff. Because I think that hopefully that worksheet kind of made intuitive sense, hopefully. Let's see. I'm going to go like this. There we go. That's better. Okay. I don't want to show the person's name because they sent me, I don't know if everybody has seen that before, but if you're ever stuck on a certain homework problem, like say this is the one you're stuck on, there's an option for, where is it? Help me solve this. If I click down there and then what? Oh, no, that's not it. Dang, there should be, well, maybe I can't click on it because I'm the instructor, but I think there's an option for ask my instructor. So that sends me an email and a direct link to your problem, because all the homework problems in Math 111, they generate random problems for every single student. So if you compare your number 9 in section whatever to someone else's same problem, they're going to have different numbers. So it's good. It's helpful for you to click on ask my instructor so I can see the exact problem you have with the same numbers and everything. So and when you go back to your homework, this is section 2.8. Let's see, wait, is this section 2.8 or 2.7? I think. Is it? This is section 2.7. Yeah. Sorry, 2.7. Okay, this is talking about inverses. A lot of the similar topics to what we did on Thursday. Let's see, but. It's this one, just I think just the way it's phrased, it's asked, okay, they give a function f of x, and in this person's homework problem, it says x plus 8, but yours might be x minus 2 or x plus something else, but I think it's very similar. So that's that one. It's asking you first, they want you to find the inverse, and you can just kind of do it intuitively, just think like we did on Thursday. This is the function that takes a number and adds 8. My inverse should do the opposite and subtract 8. So, okay, I kind of know what the inverse is, find an equation for it, okay. So they said, find an equation for it. I found it. There it is. And then they want us to verify that your equation is correct by showing that I think what they're saying, when you compose these two, if I were to take the first function and combine it with the other one, and we kind of talked about composition last Thursday, and I compose those, would I actually just get x back? So I think what they mean is if I were to do the first operation, whatever f does, and then perform the second operation, whatever f inverse does it get me back to just x? And it seems like it would make sense, because if I take a number, well, I don't care what x is, it could be anything, and I add 8 to it. Okay, and then I subtract 8. That's like I did nothing. I just undid whatever work I did. Adding 8, subtracting 8, I'm just going to get x back. So that it kind of makes sense, right? I'm going to get x back. So that one sounds good, but they want me to now type in an equation. Oops, sorry. An equation for f inverse. So I'd probably go, let's see. So then I think just the options they give are confusing. What the heck? They said, okay, well, f inverse is equal to what? Well, which one do I type it into? I think they're kind of, I think what this is referring to is the function, your inverse function, is its domain restricted, I think. So are there only certain numbers that I can put in F inverse? That's what I think this is what they're trying to say, is the domain of F inverse of X restricted, can I spell restricted? Yeah, there you go. Just as in, I think in the beginning of chapter 2, we talked about domain. Just what you're really looking for is there any roots, like a square root? Then I'd have to worry about having imaginary numbers, you know? So if my function F inverse had a square root, then I'd say, oh, the domain has to be restricted to make sure I don't have any imaginary numbers. But this guy, the one that I found, F inverse is just X minus 8. There are no roots. Okay, so I'm good there. And there's no fractions with X on the bottom. That's the other thing you got to worry about. If for some reason, I figured out what F inverse was, and then there was a fraction in there with X in the denominator. Then I'd have to worry about when would that denominator be 0, because that's bad. X in denominator. So because those are not a problem, those are the only ones you're worried about. Then the answer is no. So the domain is everything, all real numbers. Sorry, someone has a question. I see you.
Where can I find this?
Oh, this one. Well, this example. Can you see it on the screen? On my screen? I'm sorry. I should ask
Yes.
that. Okay, good. That would be so. Sometimes I'll think I'm sharing my screen and I'm not, and then everybody's like, "What are you talking about? We can't see what you're talking." Okay, that's good. This is in section 2.7 homework. I wonder if I can see. This is-
Okay, so this is not the worksheet.
Right. Yeah. You're
Okay,
right.
I thought I downloaded the wrong worksheet.
Oh, no. Sorry. The worksheet is not really related to this, but someone asked this, and I thought, well, okay, I could just explain it to this one student, but maybe it's helpful because I think the whole multiple choice thing is kind of weird. But the whole multiple choice thing, I think they're saying, okay, now that you found your inverse, is there a restriction on the domain? But in this one, no, there's no fractions. I don't have to worry about that. I don't have to worry about 0 denominators. There's no roots. So I want this first option. It just says for all X values. It's not like I have to say X can't equal a certain number because I'm worried about a denominator being 0, or X has to be greater than something because I'm worried about roots with imaginary guys. So anyway, that's all it really means. As long as there's no fractions within your function with the X in the denominator and there's no roots, then you should just be able to click on the first option. Okay, and then I'll just type in my answer. Okay, let's see. What did I say it was going to be? X minus 8, because they gave me X plus 8. The opposite of that would be minus. Let's see. Okay, nice work. Yeah, I think honestly, just understanding the concept, I think in this, especially if you were, present last Thursday, it's not so bad, but it's just trying to understand what are they asking and why are there multiple choice? What the heck? But that's all. Yeah, that's all that is. And then part B, they said verify that the equation is correct. So that they're wanting you to compose F and F inverse, which we kind of talked about on Thursday, but if you have done section 2.7 homework, then you've probably seen it more. And if you haven't done it yet, you'll see it more. So the function that was given in this example was X plus 8. The inverse would be X minus 8. We already come up with that. They're wanting us to compose them. So when they write it this way, F outside, F inverse inside, kind of like we talked about a little bit on Thursday, I'm going to take the entirety of that inner function F inverse and replace the X in the other function with it. So the F itself looked like, what was it? Looked like X plus 8, but where X was, I'm going to put this entire function F inverse. It was X minus 8. So I think we talked about that a little bit, but that's the idea. I'm going to replace the X in the outer function here, F, with whatever the entire inner function is, F inverse. And then just verify that. Does that actually simplify to just X? And in this case, I think it does. X minus 8 plus 8. Those 8s cancel and you're just left with X. Yeah, it'd be X minus 8 plus 8. The parentheses weren't really there for any reason. So yeah, okay, verified. But they want us to, I think they're wanting to make sure we're actually doing this work, this algebra. So they said, okay, it's very tiny writing. I'm sorry if you can't see it, but this says F of F inverse of X is equal to F of, so I think they're wanting you to say, they're wanting you to specify what you're replacing X with. We're replacing X with this entire function, X minus 8. So that's what I'd be typing in there. Let me see. What I do? There we go. X minus 8. Where? All right, okay. And then it's equal to And then they want you to have simplified it. Okay, well, I simplified it down to just x, so it should be just x. Okay, and now they want us to do it the other way. This, let's see, this one is where I take f and put f inverse inside of it. And then the second step is do it the opposite way. Now I want to put f inside f inverse, just to verify that either way, I'm just going to get x, that these two functions actually do undo the processes that each other does. So it's just such weird stuff. Anyway, f inverse now is outside. So I want to take x minus 8. That's what f inverse looked like. F inverse of x is x minus 8, but I'm replacing the x with the entirety of the inner function. In this case, it's f of x. And where was that guy? That guy's this one. Oh, dang it. Dang it, what did I do? I messed it up. All right, let's do it again. What? Why is it just disappearing? Oh, jeez. Here we go. Technology, oh, wonderful. I guess I'll go to the whiteboard, I'm sorry. Oh, man. At least Zoom has a whiteboard, that's kind of nice. Oh, okay. Maybe I'll see if it works. Oh, no. All right. Let's go to the whiteboard. All right. We did it one way where we did f outside, f inverse inside. Now they want us to verify the other way. Geez. Okay, now we already did f with f inverse inside. Check. Okay, now they want to verify the other way where f inverse is outside and f is inside. And I'm just a reminder that we had f, they gave us f of x is x plus 8. F inverse then would be x minus 8. Okay. So I want to, this f inverse outside, f inside means I want to take f, the whole function, and replace this x with it. So I'm replace the x in f inverse, because that's the outer guy, with the entirety of f of x. Okay, so that's one of the intermediate steps they want you to show in there. Now that in the homework they have now f inverse of blank. Now what are you placing in there? And then what do you get when you place it in there? This is what we're trying to place inside the function f inverse. So that would be what I type in first, x plus 8. And then what that means is I'm taking f inverse, which was x minus 8, and putting this inside for x. X plus 8 minus 8, of course, would give you x. So I think that's what they want. Just type in the first blank x plus 8 and the second blank x. Let's see if that works. Okay. Let's see if I can go back. All right. So now, right, I wonder if I was substituting into the outer function f inverse, and I just got x as an answer. Oh, what the heck? Oh, geez. Oh, no, it says Zoom is, oh, great. What just happened? Can you guys hear me now?
Yes.
Yeah, you're back.
What? That's weird. It just said, oh, Zoom quit unexpectedly. Do you want to send a complaint to Zoom? Okay, good. I'm glad that at least it just brought me back without asking a question. Oh, God. Okay, so it's a lot of work on these, and I almost think just the way they want you to verify that you're doing it right. They want you to prove that you're actually putting f and f inverse together in the right way. It's almost more complicated than it has to be. Let me see. I'm sure. Now we can see. Okay. Yeah, way more complicated than it has to be here. But I hope that kind of helped. And then the very last thing it looks like they're asking is, the equation is verified or not verified. Pretty much, if you get x as a result, when you compose f and f inverse one way and the other way, which one's outside? F is outside, f inverse is inside, and then vice versa. If you get x both ways, then you're verified. But if one or both of them didn't give x as an answer, it was something more than x, then it's not verified. I'm just saying, did you compose them and you get x? And then yes, I got x on both. Okay, good. And I think that's it. I think that's a bad part about these problems. You probably understand them, and you can do these problems on a midterm, as you write it out. I would say, oh yeah, you know what you're doing. But just the way they have you verify it, what do they want me to type in here? I don't understand what they're asking. So that's fun, you guys. That's fun. Let me see if I'm gonna put, well, our worksheet for today is the very first one in the week 4 module. It's the distance and midpoint formula. Let me see if I can link it in the chat. So that way you don't, if you don't, I don't know, if you can't get there right now. Okay, here we go. Distance and yeah, this is the one. Okay, I think it's coming in the chat. Did it already link? Or did it already send? It's trying. Wait, I think it's sent. If you need it, that's it. And let me see. I'm gonna go over to it. Here it is. Oh, can you see it? I think you can see. Yeah, okay. Good. It's looking good. My idea was maybe there's only a little bit of problems, you know, it's lately it seems like there's just so much to review for this class or before Math 111 material that it seemed like we went through so many pages every day of review. But now I think we can kind of calm down and slow down and just take it easy. So we might not have to take the whole class time to do this. I'll end early to answer any questions or go over homework problems or whatever. But I think what I was thinking is maybe I can go over the left ones and then you guys can try the right ones because they're pretty similar. But because they're in this section, this is preview of section 2.8 in Math 111. 2.8. It's kind of a nice break because I feel like chapter 2 is difficult. It's a lot of big hodgepodge of a bunch of topics that are not easy to comprehend and remember, but 2.8 is this nice, it's kind of simple. It's the last section in this chapter, and then we move on to bigger and better things. So it's kind of a nice place to end off, but you're given 2 formulas, and all you have to do is plug things into the formula and you're all good. But as we kind of mentioned in the beginning of class today, within one of the formulas, you'll end up doing a bunch of calculating, and then by the end, you end up with a square root, and they'll expect you to simplify it if it's able to be simplified. Some numbers, you know, like especially if the number inside the root is prime, like if it was, I don't know, 11 or something. I mean, 11 doesn't have a square root, and nothing divides in that has a square root because nothing divides into 11. So that would be just your answer. Bam, you're all done. But if there's something that divides into your number that has a square root, then you're going to want to simplify it. But and 98, this is the first example. That's kind of a big number. So I'm not super familiar with 98. I might start thinking like we did before. I'm going to kind of reverse engineer it. 1 squared is 1, 2 squared is 4. Because I know these are the guys that'll have square roots because I'm building them so that they have square roots because they're numbers that are equal to something squared. 3 squared is 9, 4 squared is 16. So these are the guys I want to see if they divide into 98. And I want to find the biggest one that does that because sometimes there's more than one number that divides in, but I want the biggest one. 36, 7 squared is 49. Okay, and then 8 squared is 64. And I'm going to keep going just maybe until I get to something bigger than 98. Then I know there's no hope for those ones. 81, I'm pretty sure it's not going to do it, but I don't know. It's kind of nice to have a big list. Oh, am I recording? Oh yeah, okay, good. So, okay, I'm looking at that. Of all those numbers that are on the right side there, what's the biggest number that divides into 98? Okay, well, 100 doesn't for sure. It's too big. 81 doesn't divide into 98. Neither does 64. 49, I think actually it goes in 2 times. So that might be the winner. I didn't necessarily know that. I don't look at 98 and just think, oh, 49 times 2. But that's why it's kind of nice to have this list written out if you're doing this homework or something, or just have them in your head. Think, you know, as if you can keep those in your mind. I think 98 is 49 times 2. Is that right? Yeah, I think so. And that's good because 49 has a square root. I'll break it into 49, give him his own square root, 2, give him his own square root. Okay, and then 49, square root of that is 7. 2 doesn't have a square root, but that's fine. At least it's kind of like at least part of it could be simplified, if not the whole thing. So that's the simplified version of the square root of 98. Yeah, and I guess that one, I don't think there were any smaller values here that divided in, so there wasn't really a lot of choices. But if there were choices like, you know, 4 divides in, but also 16 divides in, like in that other example we did, you want to pick the biggest one that does so. So that's this part. I don't think you'll have homework problems that just ask you about simplify the square root, but within a bigger problem in this section, you'll see this, and at the end, you'll need to simplify it. So how about now, just for fun, let's try it just to see how we feel about it. How about we'll all try this one. I'll just give a few minutes, you know, and we'll come back and discuss it. But 54, try to think about what is the biggest one of these numbers that divides into 54 and see if you can, you know, finish the process, simplify. Okay, I'll give it a few minutes and then we'll come back together. Okay, I wasn't sure. Is that it? Did I give you?
Professor, we're done.
Oh, done. Okay, okay.
No.
I wasn't sure. If you, I don't ever want to rush you guys if you're like, I'm still working on it. Okay. So for if you're still working on it, just ignore me for a little while, like you always do, probably. No, for 54, what did you find that was the biggest number that divides in that has a square root?
9 and 6.
Nice. Yeah, I think because 54 is, a fairly large number. I was hoping for bigger than 9. I thought, oh, probably something bigger, but I think 9's it. No, you're right. 9 times 6. Sometimes it's a little disappointing, but that's okay. At least you can still simplify it. So yeah, 9 times 6 is 54. And that's good because 9 actually has a square root. So, okay, I'm going to split it up. 9 has its own square root. 6 has his own square root. So it looks like, of course, the square root of 9 is 3. 6 doesn't have a square root, so you're all done. And then I guess if you want to, just as a last check real quick, kind of look inside the root now that remains. Okay, there's a 6. Think about, is there a number that divides into that has a square root? Can I simplify that? I don't think you can, right? There's no number that divides into 6 that has a square root. Simplify. So you're done. Go to 6. Yeah, but like in mine, well, or like, the one we went over earlier, 32, if I had done 4 times 8, then I would be, oh, that's 2. And I think I'm done, but then I look inside the root and say, wait, 8, there's something that divides into 8 that has a square root. So I'm not done. I should do more. Yeah, but you could have saved time and just split it into 16 times 2 instead, like we said, yada, yada. Yeah. Okay. Nice. I think you got it.
Wait, Professor? So the answer for square root of 32 is 2 square root of 8, correct?
4 square root of 2.
4 square root of 2.
Yeah, because you're supposed to split it into the biggest number that has a square root, which is 16 times something. So this would be kind of halfway there. You're halfway there, but you need to go all the way till what's inside the root can't be simplified anymore.
So the number inside the root has to be, it's still the same. It's the square root of 2. It's just the outside is 4 and 16, correct?
Oh, you mean, is this the answer here? The 16 root 2?
Yeah, I just don't understand how it can't be 2 times the square root of 8. That's where I'm lost.
So you're halfway there. You simplified it a little bit, but this can be simplified more because 8 has something that divides in. You'd have to simplify it again by breaking 8 into 4 times 2. And then simplify that 2 times 2.
Okay, I see.
Yeah, but you would have foregone all that extra work if you just went straight to, instead of 4 times 8, do 16 times 2. Then you wouldn't have to simplify twice because you found the biggest number that divides in that has a square root.
Thank you for finally demonstrating square root of 32. I wouldn't even know the answer. I thought the answer would be 2 times square root of 8 if you wouldn't have demonstrated it right now.
Yeah, good. I'm glad that helped. Because I would do the same thing, like, oh, I simplified it. Why is it marking me wrong? But that doesn't happen too often, but when it does, it's kind of annoying. Like, really, what did I do wrong? You didn't do it wrong. It's just that you could have gone a little further. That's all. But it's hard to recognize that, when can I keep going and that. But that's pretty much it. Just when you think you're done, look at the number inside the root and say, does anything divide into that little guy that has a square root? And if not, then you're done. Yeah. So this section 2.8, that was, so far we haven't really done anything new, for Math 111. That's just review.
Wait, Professor, hold on. So if that's the case, what about 3 times square root of, square root of 6? That, we look at 6 and it looks like it can be divided too, right?
Well,
So
6 you can write as 2 times 3, but neither of those has a square root. So that's not, it's not really advantageous to split it up. But 8 can be written as 2 times 4, and that's good because 4 does have a square root. So I guess that's the idea. 8, one of the parts of 8 has a square root, but neither part of 6 it has a square root. 2 and 3 don't. So you could split it up, but it's not really helpful because they're stuck in the root. Nobody can escape from the root in that case. But with 8, you can. Yeah.
okay.
It's kind of a weird. I don't know. That's such a weird topic, and if you saw it in algebra in high school or wherever. It was one day you saw it and then you never see it again. And then all of a sudden, 2 years later in another math class, they say, how do you not remember this thing that you learned 2 years ago for one day? Like, what? Who does remember something from 2 years ago? I don't know. Yeah, that's silly. But the main thing in this section is there's 2 formulas that we use, and there's no word problems and no funny business. It's just straightforward stuff, which is kind of nice. I feel like like I said, I think this is a nice way to end this chapter. It's been difficult. And if you've gotten through it and you feel like fairly comfortable with it, I think you're doing pretty good because it's not an easy chapter. Yeah, so don't, yeah, you're doing good. So the main thing is it wants you to be able to take any 2 points, like on the XY coordinate system, say, just any random 2 points. I don't even know what they are. I'm just gonna call them, I don't even know what this point is. I'm gonna call it X1 and Y1. You know, just because it's the first point, and it's the X value and Y value, and this is my second point, so I'll call it X2 and Y2. Okay. And I think what they would want to do, there are different times in math, I guess, probably in future math classes, where you want to know a few different things. First, maybe first of all, what's the distance from one point to another? What is that distance? And, you know, of course, distance would probably just be a number like 5.7 or something, some measured distance, like, you know, when you drive from here to there, how many miles did you drive? So it should just be a number. That's the one that'll probably be a root. You'll end up with the root because we'll see the formula pretty soon, but the formula ends up having a root in it. Okay, and then also another thing you might want to know, maybe in some other math classes, not only the distance between them, but what's the point right in the middle of the two. Any 2 points that you can draw on the XY coordinate system, there's probably one point that's directly in the middle of them, and they call it the midpoint, which is kind of nice. That's a good name. I can kind of tell what they're talking about. Midpoint. But that one, unlike the distance, where distance between two things is just a number, a midpoint is actually a point. So your answer,
Sorry to interrupt you. I'm sorry. You said 9 comma negative 1.
what's that?
Did you say 9 comma negative 1? 5 comma 3 and 9 comma negative 1?
Oh, for the examples?
Yes.
Or no? These, yeah, you're right. 5, 3, 9, negative 1. Yeah, that's the
So
first.
if
Wait,
it's a
but-
negative 1, if it's a negative 1, shouldn't it be below, like for the
Oh, this-
Y2?
what I'm drawing now is just 2 random points. They're not from the examples, maybe. They're just random points, but they could be anywhere.
Or-
Yeah, this is just to illustrate the idea where we get the formula and why it is the way it is. But this is not one of the specific problems on this worksheet. It's just more like to get the idea behind distance. What does it mean? And midpoint. Yeah. And I think there's probably all varying levels of how much people care about this. I have a feeling people don't care too much. But if you think about those 2 points over there, I don't know if I drew that very well, but the distance between them, the way you get the formula is you make a little right triangle by drop kind of, yeah, like this. And it ends up that the sides of the triangle are the horizontal part. The distance is x2 minus x1. It's the difference in the x values, and the height is the same for the y values. So you get the distance by using the Pythagorean theorem. Fine. That's where the formula comes from. You don't need to know that, but just in case you see the formula and you say, what the heck? Who comes up with this? Find distance using the Pythagorean theorem. Well, remember that one? I don't know why, but for some reason that's the one that everybody remembers. And I feel like in school I remember it too, but I didn't use it much in my life. It was like a squared plus b squared is c squared, and c is supposed to be the hypotenuse or the longest side. So anyway, that's just if you care. Most people don't care, but if you just want to know the formula, the distance formula, it's the square root of parentheses x2 minus x1 squared plus another parentheses squared with the same thing except with y's, y2 minus y1 squared, and that's all under a square root. So that I think that formula, you know, in the problems in the homework, you're just going to be given 2 points. Okay, this is like the first point or the first example that's on this worksheet, 5, 3, and was it 1, negative 9 or something like that. All you have to do is put the right numbers in the right place and simplify it down. Kind of like with the slope formula, you know, when back in the early parts of chapter 2, it said, here's 2 points, find the slope of the line between the 2 points, and you just plug in x1, y1. So it's a lot like that. I think the main thing on this one to keep in mind is it's kind of a complicated formula. It's got a big square root. It's got these squares on it. It's got subtraction in the parentheses. Just keep in mind you want to use order of operations when you do these problems. That's important. Order of operations. So for sure, because there's subtraction inside the parentheses, that's the first thing you'll do when you plop in values for x2, x1, y2, y1. They're all numbers. Do the subtraction first, and then once you do that, the next thing would be squaring them, because that's directly, you know, exponent should come first after parentheses, exponent, and then do any multiplying or dividing, but there's not really any multiplying or dividing. Then you'll add the middle thing. And the very last thing you should do is the root, because that's the very outer thing. So we'll do an example like that. Maybe we'll leave that formula there and do this example. Okay. Maybe I might have, oh, sorry, go ahead. Someone has a question. Go ahead. I'm sorry.
The last two examples are the same as the top two.
Oh, okay, that's right. Well, that's okay because one of them is asking for the distance and the other one's asking for the mid.
Oh, okay. I didn't see that part. Okay, never
Yeah.
mind.
Good question though, because then it'd be like, okay, we're gonna waste a bunch of time doing the same thing twice. That's a good question. Yeah. I don't know why I did that. I guess I'm not creative or something. Is that what that's probably what it is? Yeah, pretty much. So I'm just gonna write it just so the formula, it's right in front of us. We don't have to go looking for it over here, and it's gonna be right in front of us. Okay, I'm gonna write it again. Square root of x2 minus x1 in parentheses squared plus y2 minus y1 in parentheses squared. Okay, that looks good. Now I just have to kind of like with the slope. I think we have an advantage on this because we've kind of done something like this before with the slope formula. The first point that was given, or the leftmost point, it's 5, 3. 5 is its x value and 3 is its y value. So I'm going to call that x1, y1. And then the second point given, the x value is 9. I'm going to call that x2, and -1 is the y value of the second point. So I'll call those x1, y1, x2, y2. But if you were to switch them, if I call 5, 3 my x1, y1, and then 9, -1 my x2, y2, but you switch them, if you did it where you said, I'm going to call the rightmost point x1, y1, and the leftmost point x2, y2. If you plug it in the formula, it looks different along the way, but you'll get the same answer. So it really doesn't matter which point you let be the first and which one you let be the second. Either way, okay, I'm gonna just try to substitute these in. Square root of a big old thing going on. I'm gonna leave the insides of these parentheses blank because I'm gonna replace them with numbers now. Okay, the very leftmost thing I'm supposed to replace x2, I assign that to be the 9, huh? Okay, and then minus x1, that was the 5 from the first point. So far, so good. Then we got y2 in the second parentheses. I assign that one to be -1 minus y1 would be the 3 from the first point. All right, that's like, I think the hardest part is putting all the right numbers in the right place and not missing any negatives or subtraction signs or blah, blah, blah. Okay, now we need to do order of operations. So I'm gonna do what's inside the parentheses first. So 9 minus 5, that's 4. And I got the square outside plus, and then this one, -1 minus 3 is -4. Squared. Okay. And now this is tempting because I know, in other parts of math, you'll see like a square root of x squared, for example, and those are opposites. Actually, like in the inverse section, the previous section to this one, if you see a square root and a square, they cancel each other out. You know what I mean? And you're just left with x. So that's very tempting to do that here because I see a square and I see a square root. If it was just like the square root of just 4 squared all by himself, then I could cancel them. But because there's a plus and 2 different terms running around inside the root, I can't simplify it. So it's going to be very tempting. You're going to want to cancel the square root and the square, but we can't do that. And it's because there's lots of terms or there's 2 terms inside of these parentheses or inside of the root. So we actually have to do all the math and no canceling, unfortunately. I wish. So now the next thing would be I did parentheses, now exponent. 4 to the second power is 16 plus. Now, -4 to the second power is also 16 because that's -4 times -4, which is +16. So really inside the parentheses, or sorry, inside the root, I have a square root of 16 plus 16. And then also at this point, I'm not able to split this into 2 roots. So earlier, when we were simplifying radicals, one of the ones we did, like we were talking about, square root of 32 is 16 times 2. And then I'm able to split it into 2 roots separately. That I can only do that when I'm multiplying or dividing inside of a root. But when there's a plus like this, or if there was a minus, I can't split it into 2 roots. So unfortunately, the root is the last thing you want to do. You want to simplify what's under the root all the way down to its one number. Like this 16 plus 16, I have to actually add that. Oh, that looks familiar. Interesting. I don't even know if I did that on purpose. Yeah, so that's your answer. But this is where, the homework or on the midterm, it would be, okay, you got it right, but we want you to simplify it. So I need to split it into 2 numbers, one of which actually has a square root, and we already did this. So I guess I don't have to really put a lot of thought into it. 32 is 16 times 2, and that's a good idea because 16 has a square root. So really, this is what you want. I don't really want that, even though it's right, it's not simplified all the way. And that's it. But notice if you would have, I think if you would have done anything in a different order, or like here mistakenly said, oh, I can square root 16 and 16 separately, that would have been 4 plus 4, which is 8. That's not the right answer. It's not the same as ours. So you really, it feels like you want to make it easier or quicker and cancel stuff, or It really is, the very last thing you do is the square root. You can't cancel it with the squares, you can't really, yeah, it's a bummer, but in the end, you're just gonna have a square root of a number. Maybe it can be simplified, maybe not. Yeah, that, that one, when we simplified it, or when we combined all the terms, we got the square root of 32, but if it was something like the square root of 31, for example, I'd be done. I don't have to simplify it because 31 has nothing that divides in that has a square root, so that would be my answer. It's only if you happen to end with a number that has a square root, then you have to do more work. Yeah. So that's the distance formula. I think what I'm gonna do is leave this one for you guys to try after we're done here. I think we'll break into groups. I know everybody hates that. You'll try that one. You try, work on it together in your group, and then this one as well. So together we do one distance formula, and now we're gonna do a midpoint formula, and then you guys try the distance and the midpoint for these 2 points, and then we'll come back together and discuss. But it's good to get your hands dirty. Sometimes you listen to a math lecture and it makes sense, and then when you go home and try the homework, you say, oh crap, I thought it made sense. Maybe it doesn't make sense. So it's good to try it while we're here, and you can ask questions if you're stuck or whatever. So okay, now for these bottom 2 problems, it's the same points, but they want now the midpoint formula. And like we kind of discussed earlier, so the distance formula, you're finding a number. The distance from one place to another is just one number, but the midpoint is a formula that actually gives you a point as an answer, which is kind of weird. It's kind of a strange, anyway. But the midpoint formula, we haven't talked about that yet today, but it's going to be, it's really what it is that your x value of your midpoint is the average of the 2 x values. So take the 2 x values of the points you're trying to find the midpoint between and average them, add them together and divide by 2. That's how you find the average. Like if you took 2 exams and I want to know what was my average score on those, I'd add them together and divide by 2. And then the same thing with the y value. My y value of the midpoint would be the 2 y values of the 2 points given divided by 2 after I add them together. So that's the formula for the midpoint. It's a lot simpler and it's a lot quicker to do. It just looks strange. It looks complicated and it's weird, but it's definitely good to expect just one number as an answer in your distance formula, like we got 4√2. That's just some decimal value. But then in this one, we're going to end up with a point. It's going to be x value, comma, y value as an answer. So I'm just going to, I already assigned in the previous problem, these are the same exact points. So I'm just going to keep the x1, y1 the same. 5 is my x1, 3 is my y1, 9 was my x2, -1 was my y2. I'll just replace those, but now in this new formula, because now they want midpoint. So, okay, let me see. Just as long as you replace everything and you go carefully, then it should be okay. X1 plus X2 will go in the first coordinate divided by 2, and then Y1 plus Y2 divided by 2. Okay. And my X coordinates were 5 plus, and the other X coordinate was 9. Divide that by 2. I'll simplify that later. And then the Y coordinates are 3 and -1. So just kind of, yeah, just replacing your X coordinates, 5 going here and 9 going here, and then 3 going here and -1 going here. And then just simplify. Let's see, in the first coordinate, 5 plus 9, I'm going to add those first. 5 and 9 makes 14. Divided by 2, I know that simplifies. And then the second coordinate, 3 plus -1 is +2 divided by 2. And both of those simplify. I got 7 and 1. So if I were to, I guess the idea is if I were to plot those 2 points that were given to me, the 5, 3, this point, and then the other point, 9, -1, the point that's directly in between them, if you were to draw a line from one to the other, the guy that's, excuse me, right in the middle is that one. So that kind of makes sense. If you want something in the middle of 2 things, you would average. So X value would be the average of the 2 X values, and then same for the Y values. Yeah, but let's say, I think if I remember right, I think when you do the next example, the midpoint of the other 2 points that you guys are going to work on, I think when you get to this stage, I think one of them doesn't simplify. So if for some reason in the first coordinate, instead of getting 14/2, if I had gotten 15/2, like if I was given different values, then that first one I can't really simplify. I just leave it the way it is because 15 is not divisible by 2, but 2 is divisible by 2. So I guess just keep that in mind. If when you add the 2 values in the numerator, if it's an odd number, it can't be divided by 2. So you could just leave it as a fraction. That's fine. But if it's an even number, of course, it can be divided by 2. So go ahead and do that. So I got kind of lucky, I guess, sort of that this 14 in the numerator and this 2 in the numerator are both even. So I'm able to simplify them. But yeah, if either of them were odd, I would just leave them exactly as they are. Whew, that's a lot of work. So how about, well, yeah, that's all we're doing today. So I think just maybe for the next 10, 15 minutes or whatever, how long it takes, I'll let you guys try in a group the remaining ones, the points 0, 4 and -5, 2. try to do the distance between them and the midpoint between them, and then just kind of see, you know, compare your answers, make sure that you all got the same thing. Yeah, let's see. Okay. I'll break into groups and then we'll see. I'll try to go around and see if you need help and stuff like that.
So Professor, do we do them in the break room or do we do them before going in the break room?
I guess it's kind of up to you. We're all gonna go in the rooms right now, and I noticed some rooms they all do them separately, so it's quiet, and then they compare. Maybe that's a good idea. Maybe work on it and then compare after you're done. Yeah, that might be good.
Wait. CG.
Oh. 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 Well, I don't know if we will, but the day was track, I think, but, yeah. No. They're on. Yeah. Gee. Forgot to resume the recording. Yeah. Well, if anybody missed it, it's written out up here. Oh my gosh, come on. But I was gonna mention that when we take our first midterm, we got a few weeks till it, and we'll talk more about it as it gets closer, but for each midterm, you can have a little sheet of notes, like a 3x5 note card. You can write anything on it that you want front and back, like formulas, or even if there's a certain type of problem you think, oh, I don't think I'll remember how to do that one, so I'm going to write it down. You can even write examples down so you can follow along. So this might be something to write down, is these formulas here, distance and midpoint, because I guess if you memorize them on accident, then you don't have to write them on the note card, but it'd be kind of nice to have them just in case. And now I realize that first I wrote the formula down wrong. It's supposed to be the x's together in the first numerator and the y's together in the second numerator. Oh my gosh. Let's see now. Okay, x1 is 0 plus x2 is -5 over 2. Okay, that one's going to be an odd number over 2, so it's not going to really be able to be simplified. y1 is 4 plus y2 is 2. All right, so the leftmost component, the x coordinate, is just going to be -5 over 2, and that's fine. I mean, I guess you can make that a decimal, but I think they just want you to leave it as a fraction on the homework. And then the second component, the y coordinate, 4 plus 2, 6 over 2. That one actually simplifies because it's an even number, which is divisible by 2. So I'm going to go ahead and do that. And I think that's good. That's a good answer. Whew. We did it, everyone. So I think now probably this homework, it'll just be super easy when you get to section 2.8. I think at that point you've paid your dues, because chapter 2 has been very difficult, well, in my opinion. And now this section is pretty good. That's a nice way to end off